Let's talk about clustering columns. Now, clustering columns are the other half, the second part of a primary key. Primary key, most important part of your data model in Cassandra. Now, we talked about partition keys. Clustering columns are that extra piece that really make it work. And they're not optional. You really need to understand how these work. And once you have that combination of partition key and clustering column working for you, you'll have a really awesome data model. Let's look at this table. We have a partition key which uses state. Now, that's going to group all these states together. So if you have Texas, for instance, that means all that data is being co-located in the same file, on the same disk, on the same node. But this also gives us a really thin piece of uniqueness to this data. State is not enough, and we want to control some order. So if you do a group by, for instance, in a relational database, this would be group by state. But how do we control order and uniqueness in our data model? Now, the primary key, again, controls uniqueness. In this case, we're going to add that clustering column for city. This means that we want to make sure that the city is being used to sort all the data from Texas. So in this case, with city being the sort order, in ascending, that means it goes from A to Z and in Texas. So all that partition data is ordered properly. So this is an order based on city. What if we wanted to order it by something else, say the name? And we got some really awesome names in here. I might want to sort these like Lone Star or a compact one or Dev Awesome, which is my nickname. So if we do that, we have to change the primary key. Now, you can't change a primary key if you have an existing data model. Let me be cautious here. You're not going to go into a data model and say, I'd like to do an alter table and change my primary key and add name. This is something you do way ahead of time before you insert data. If you have data in the database, you can't change the primary key without redoing your data model. So I'm just going to make sure we get that warning out there. But for the sake of example here, I've changed the primary key to be state and name. Now, the name now will be the sorting. So as you can see, now we're sorting by name. The state is a partition key. That means that that's all the data that's grouped together. And in this case, the city doesn't really matter so much because we haven't asked it to be sorted by that. But we could, and in this case, we added it. Now, clustering column is always the next columns after the partition key. And you can have one or more, a lot of them as a matter of fact, and it's just how much order and uniqueness you need to add to your database. So that primary key is really becoming super important at this point. So in this case where we added not only city, but name, we're saying first order by the city, and then order by the name. Now we have this really neatly ordered database that might actually work really well for our application. In this case, our query may need to look at city as an order, but also by name. And we've pre-sorted all this information. So now with this clustering column in place, when we insert data into the database, it's going to go onto the disk in this order. And that is pre-optimized and really super fast, really handy. But hold on, we have a problem. The problem here is that city and name are not unique enough. That state, all right, there's going to be a lot of people that live in one US state. There's probably a lot of people that live in the same city that with the same name. So if we created a primary key with state, city, name, you're going to run into collisions. And the way Cassandra works is it doesn't go by uniqueness. So you're going to have this situation where you insert data into the database and it'll start overwriting records, and that's not what you want. How about adding something in there that creates uniqueness in the record? In this case, we've added ID. Now, this is an ID that we've created. There is no incremental value inside Cassandra. I know a lot of relational databases do that, but that's a very difficult thing to do with a distributed database. In this case, we're using an integer, which gives us that uniqueness of that value finally with the city, state, name, and then a unique number. So in combination, this is a unique record, and we're guaranteeing we won't have any kind of collision. Now, there's a lot of techniques on how to avoid collision. This is a very simple use case, but this gives you an idea of what you're trying to accomplish. The primary key is solving two problems here, a unique record and controlling the order. But you can control the order a little more. So now that we have this really nice primary key, we can also use order by in the query to alter that order as well. So not just whenever you insert the data in, you do have the option at runtime when you run a select query to get a different order. So for instance, when you do a query, you say order by state, order by name, and it will optimize for that order by. So one thing you may have noticed here is the state has parentheses around it. So you may be wondering why. Well, that is part of a partition key. It is optional to put parentheses around a single partition key. However, if you have more than one partition key, you have to have it. That topic is covered in a later video. Now, speaking of queries, let's talk about that. What can this enable? In the case of whenever you use a primary key that has partition key, clustering columns, each one of those is unique and helpful in your query. First of all, every query should have a partition key. And the reason being is because you need to be able to find that data in your cluster. If you don't provide the partition key, you're doing a random look around the cluster and you don't want to do that. How about let's go find the data? Probably not the right idea. We want to be specific. That's why partition key is really important. However, once you're inside the partition, you can do some really neat things like equals, greater than, less than. Any kind of an inequality query, that's all legal inside a partition. And the order of those clustering columns is also super important. If you're going to be looking for particular items, if you're saying equals, you have to do it in the order that the clustering columns are presented in the primary key. So in the case where it was state, city, name, if you're doing an equality, you could say state equals Texas, city equals Austin, then it will give you everything beyond that. If you did a state equals Texas and a name equals, Dev Awesome, well, that wouldn't work because what you're doing is you're putting the name ahead of the city, which is going to be out of order on the primary key. And it will tell you that. If you do this query, the query will return as an error saying you're doing it out of order based on the clustering columns. So just know what that means. Know that you have to do your queries in order of the clustering columns. But when you do, you get some very powerful queries that you can get out of your data. Now, when we do these searches inside of our queries, we're actually taking advantage of what we did on disk. And that is the data is sorted in a certain way because of our data model. And it's going to take advantage of a binary search on disk. And that's really going to be a fast data model. Now, what if we want to change the order? Now, whenever we create a primary key and we include the clustering columns, the default ordering scheme is ascending. What if that doesn't work for you? Well, we have a clause that you can add to your data model, clustering order by. Using that, you can control the order of the clustering columns and turn it from ascending to descending, which can be really handy in certain use cases. Think of, say, like a time series data model, where instead of having ascending in the time, you want to have it descending, meaning the last thing that happened is the first row of your data. Using clustering order by is really useful for certain use cases. For instance, time series. Time series lets you change the order of the time data. For instance, if you use a date time or a time UUID, then it'll let you reverse the order of that data stored on disk. So this data would be the first part of that data model. So you will always see the latest data first. That can be a really handy thing to have, especially in speed required applications such as fraud detection. And that is something you can control way ahead of inserting data that makes it much more efficient. So in the case where, say, you may put in select star from user, that seems like a pretty reasonable query if you're in a relational database. I just want all the user data. But in a large-scale database like Cassandra, where there's multiple nodes and they're spread out all over the place, that is possibly one of the worst queries you can do, because what you're basically telling the system to do is go look at every single node and give me every single piece of data in the system. Not a good idea. So it may prompt you to say, you should also think about using allow filtering. Stop. If you think that's what you need, you're probably wrong, because that has been put in there for very specific use cases and to allow for people to actually do a full cluster query if you have to. If you think you have a database model that needs that, think twice. You probably don't. But just know what it does, and when you use it, your eyes are wide open. Now let's do an exercise with clustering columns so you can really get some practice on how they work.